In this video, we will look at graphing rational functions. What are rational functions? Rational functions are any function that can be written as one function divided by another function. Let's look at the rational function 2 divided by x plus 2. Take out your graphing calculators and put that in. Remember, anytime you put in a rational function, if you have something more than a monomial, if you have a polynomial in either the numerator or the denominator, you must put it in parentheses. Otherwise, the graphing calculator doesn't recognize it. So we have 2 divided by x plus 2, and we graph it, and there's our graph. And we can see from the graphing calculator we have an asymptote at x equals -2. So the domain of this rational function is all real numbers except x equals -2. So in this graph we have an asymptote, a vertical asymptote at x equals -2. We also have a horizontal asymptote at y is equal to 0. We're going to talk a little bit about some new limit notation. We have an asymptote here at x equals -2. So we have a limit as x approaches -2 of the function f of x, but it's approaching it from two different sides. So as we are approaching it from the positive side, we put a little plus here, which says we're approaching it from the positive side. There, the limit is going toward infinity. And the limit as x approaches -2 on the negative side, so it's a little minus up there of the function f of x, we are getting closer and closer. We're headed down to negative infinity. Here are these limits written out a little bit neater so that you can actually see how they should look. We're going to look at some rules at how we would graph a rational function. We're going to look at the asymptotes. For a rational function, what we want to look at is the degree of the numerator and the degree of the denominator. So if we have the degree of the numerator is less than the degree of the denominator, then we have a horizontal asymptote at y equals 0. An example is the 1 over x. 1 over x graph looks something like that. And we have horizontal asymptote at y equals 0. And the degree of the numerator is 0. The degree of the denominator is 1. So anytime the degree of the numerator is less than the degree of the denominator, there will be a horizontal asymptote at y is equal to 0. If we have the degree of the numerator equal to the denominator, then we will have a horizontal asymptote at the quotient of the leading coefficients. For example, if we want to graph the function y equals x plus 3 over x plus 4, we will have a horizontal asymptote at 1 over 1 or 1. So I'll bring up the graphing calculator there. Here we have x plus 3 over x plus 4, and we can see our horizontal asymptote is at 1. If we change that to, let's say, 2x plus 3 divided by x plus 4, now our horizontal asymptote will be at 2 divided by 1, or 2. And one more time, let's change this to, how about 2x plus 3 divided by 6x plus 4? The degree of the binomials is still the same, so we're still looking at 2 divided by 6, which is 1/3. So our asymptote is at x equals 1/3. If we zoom in our window, let's change the y scale, -3 and a +3 to really zoom in on that so you can see there's our 1/3, our asymptote at 1/3. The third case is if the degree of the numerator is greater than the degree of the denominator. What we do in that case is we divide the numerator by the denominator and we throw away the remainder. There will be no horizontal asymptote. There will be what is called a slant asymptote, and that will be the equation of the quotient. Let me show you what I mean by that. If we have an equation such as x squared plus 2x minus 3 divided by x plus 2. Here we have the degree of the numerator is greater than the degree of the denominator. To find a slant asymptote, we're going to divide. And because we have x plus 2, we can use synthetic division here, which gives us 1. 1 times -2 is -2, 0, 0, -3. We can throw away the remainder. This tells us we started with x squared here, so we go 1 degree down. We have y equals x plus 0, so y equals x is our slant asymptote. When we get into graphing, I'll show you a little bit more what that means. And just 3 more points here. These are things we've already discussed. The vertical asymptotes occur at the zeros of the denominator because we don't want to be dividing by 0. The x-intercepts occur at the 0 of the numerator. So when the numerator is 0, that means that we'll be crossing the y-intercept. And the y-intercept is when we make x to be 0. We put it into the equation and find the y. I'll give you examples of all of these. All right, the first one here. We have the degree of the numerator is equal to 2, and the degree of the denominator is equal to 2. So that means when they're equal, the asymptote is going to be the quotient of the numerator divided by the denominator. So we will have an asymptote at y is equal to 2. This is a horizontal asymptote. And we have vertical asymptotes at x equals -1 and x equals -5. Let's put this on the graphing calculator and confirm it. So remember, when you're putting this into your calculator, you must have parentheses around the entire numerator and the entire denominator. Otherwise, the calculator will not know to group them together as the numerator and the denominator. So I have parentheses around the entire numerator, parentheses around the entire denominator, and I'll graph it. And we'll see our horizontal asymptote at y is equal to 2. And we have 2 vertical asymptotes, x equals -1 and x equals -5. Let's look at another example. This time we're going to graph it without the graphing calculator. We can check it with the calculator at the end. We've got f of x equals x minus 1 divided by x minus 2 times x plus 3. First thing we're going to look at is our n and our m. The degree of the numerator is 1. The degree of the denominator is 2. So n is less than m. We will have a horizontal asymptote at y is equal to 0. And we will have 2 vertical asymptotes at positive 2 and -3. Let's put this on the graph. So asymptotes, I'm going to go ahead and put those in a different color. Let's make them red. So we know that because n was less than m, we have a horizontal asymptote at y is equal to 0. We know that we have vertical asymptotes at positive 2, and we have a vertical asymptote at y equals negative 3. Those are our asymptotes. Now, we want to figure out our intercepts. We want to know where it crosses the x-axis and where it crosses the y-axis. It's going to cross the y-axis when x is equal to 0. So if x is equal to 0, we have f of 0 is going to be 0 minus 1 over 0 minus 2, negative 2, times positive 3, which is negative 1 over negative 6, or a positive 1/6. So at 1/6, when x is 0, y is going to be 1/6. So it's going to cross right there. Now we need to find out when y is going to be 0. Y is going to be 0 when the numerator is 0. So x minus 1 is equal to 0 when x is 1. So when x is 1, the y is 0. We can make our graph. So our graph is going to come in. Very hard to do. That's a very poor graph there. I'm sorry. I'll show you on the calculator. I can't erase it or I'd erase everything on there. But it's going to come in there. And then what happens is we come in over here and we come in over there. So we have a 3-part, very bad drawing. So let me bring over the calculator so you can see what it really looks like. And even this is not a great representation because this should continue down here. This crosses over, and then we get a 3-part graph there. And let's look at our third example here. We have x squared minus 3x minus 7 divided by x plus 3. The exponent, the degree of the numerator is 2. The degree of the denominator is 1. So in this case, n is greater than m. So we are not going to have a horizontal asymptote. We will have a slant asymptote. So we need to divide. We'll use our synthetic division. 1, negative 3, negative 7. And again, the remainder doesn't matter. So what we have here is x minus 6. Y is equal to x minus 6. That will be our slant asymptote. Let's put this all together on the graph. So we have our slant asymptote at x minus 6. Remember, y equals mx plus b. So negative 6 is our y-intercept. 1, 2, 3, 4, 5, 6. And our slope is 1. So there's our slant asymptote. We have a vertical asymptote at negative 3. Then we want to find our intercepts. So when x squared minus 3x minus 7 is equal to 0, if we factor that, we're going to have our intercepts. Factors of 7, that's not going to come out evenly. So in this case, we'd have to use the quadratic formula, which I'm not going to use right now. So let's just look at our y-intercept, where x is equal to 0. So we have 0 minus 0 is going to be negative 7/3. So when x is 0, y is negative 7/3. So what we have is a graph that comes in here and goes like that, and then it will reflect across on the other side of that. I'll show you a much better example in class. The important thing to remember from this example is the slant asymptote. And now I leave you with this: math. Some are better at it than others. See you in class.